Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve 12th problem of dynamic programming study plan maximal square. Let's look at the problem description. Given a m by n binary matrix filled with zeros and ones, find the largest square consisting of only ones and return its area. Okay. So if you see in this particular example, you can see this is a square of length 1. Okay, this is a square of length 1, this is a square of length 1, and this is a square of length 2. Okay, so area of a square whose length is 2 will be 2 times 2, which is 4. So area of this particular square is 4. Area of this square is also 4. You can see we cannot form any other square with maximal area other than 4. So the maximum area you can form is basically 4 with all ones in it. Let's also look at the second example. If you see, this is contributing to a square of length 1, so the area will be 1 times 1, which is 1. This is also contributing as a square, so area will be 1 times 1, which is 1. So the maximum area you can form is, in this case, is 1. Okay, let's say we are standing in a particular grid, okay, I comma j. If the particular grid consists 0, that means I cannot form a square using this particular grid. Okay, I cannot extend this particular grid in any other direction, so it can form a square with all ones. So whenever we have 0, that means answer to form square using this as a top left corner of my square is 0. Okay, I cannot form square using this particular cell. Let's say I'm standing over here. Okay, now I will say keep this as a top left corner of my square and try to extend it. Okay, extend it in this direction, in the rightward direction, down direction, as well as in the diagonal direction. Okay, whether we can extend it or not. Okay, in order to extend it in right, diagonal, and bottom, we should know what is the maximum length of a square which can be formed from the right cell. Okay, the maximum area you can form with the right cell is basically 2 over here, right? The maximum area, maximum length you can form using this particular diagonal cell is basically 1, because this itself is a square which is contributing as a square. You cannot extend it to a length of 2 because we have a 0 over here. The similar fashion, this cell will contribute to a length of 1, right? So we have to take minimum of among all these things. Okay, then only the corresponding length will be added to my current cell, and then it will be extended as a square. Okay, if you see, length of 1 square can be formed in the bottom, length of 1 can be formed here, and length of 2 can be formed over here. The minimum among all these 3 is 1. That means I can extend 1 unit in the right diagonal as well as in the bottom. Okay, then only I can form a square. In order to extend a square, I should extend it right, diagonal, as well as bottom. So that is what we are doing. So we will define a state as f of I comma j, which will tell me the maximum length of a square you can form keeping this I comma j as the top left corner of my square. Okay, if the current value, if it is 0, or if I am exceeding the bounds, if we are exceeding the boundaries, that means I can not form a length, I cannot form a square, so I will be returning 0 as the length, or else I will be contributing this as a single unit for my length, and answer coming from the right diagonal as well as bottom. So this is basically answer coming from the right. This is the answer coming from the diagonal, and this is the answer coming from the bottom, where the current cell consists of 1, right? Let's just try to implement this using top down approach. Okay, so I just define few variables at the class level, and then as you can see, if you draw the tree diagram, you will notice that there will be certain states which will be overlapping. As a result, we are using dynamic programming and caching those values. Okay, so if you see I and j, okay, let's look at the function I and j. Okay, I is taking from values 0 to n, and j is also taking values from 0 to n. So I need to define a a 2D array of size m by n, right? So if the current cell is 0, or if I am exceeding the boundaries, that means I will be returning 0, saying indicating that the square, we cannot form a square of any length. Okay, and we will be getting answer from the right diagonal and bottom, and getting the minimum among all those things and contributing 1 to it, which will be answer to the current cell. Okay, I am storing this value in order to reuse it for the future. Okay, so if the answer to a particular state, if it is already computed, then I will be simply returning it, or else I will be recomputing the answer. Okay, and what I have to do, I have to check what is the maximum length square I can form from each of the position in my original grid. So that is what I am doing here. So I define initially the max as minimum value, and checking that keeping each grid as the top left corner, what is the maximum length I can form, that is what I am computing, and I am trying to maximize it. In the end, my answer will be max times max, which will be the area. Okay, if you see, the time complexity of this algorithm is order of n square. Okay, and the space complexity is basically m into n. Time complexity order of m into n, and space complexity also order of m into n. Reason being, we are populating all the states of m by n. Okay, let's also try to implement it in the bottom up fashion. Okay, in the bottom up fashion, we will be starting from the bottom left corner and then filling the values in the backward direction. First we will be filling the values in the m-1 row and then m-2 row, and so on and so forth. Again, in each row we will be filling the values in the backward direction, which will be n-1 column, n-2, and so on and so forth. Okay, if a particular cell contains value as 0, that means I cannot form a square keeping the particular grid as a top left corner. And if it is 1, that means I should get the answer from the right bottom. This is bottom, this is right, and this is diagonal. Okay, so in the end I have to maximize my area, maximize my length. So my max will contain the maximum length among all the space which can be formed. In the end I have to calculate the area, which will be the max times max. If you submit this problem, all the test cases will be passed, and it will be pretty efficient solution. The bottom up approach is better than the top down approach only in one aspect. Here we don't have a recursion stack. Okay, so the space coming from the recursion stack can be saved. So that is the only benefit coming from the bottom up approach. Rest everything remains same. Okay, in terms of time complexity and the space complexity. That's all about this problem. If you like the explanation, hit the like button, hit the subscribe button, and share your valuable feedback in the comment section. I will be posting the solution, and I will be pinning the solution in the comment section. Feel free to check it out. I will be posting solution in multiple languages, Java, JavaScript, as well as Python. Anyone who is coming from other languages can also check out those solutions as well, because the core logic to compute the answer will remain same irrespective of what language you are coming from. Okay, that's all about this problem. Thank you.